All right. If you remember correctly, this was a problem we were trying to balance with our new redox system balancing. And when we started analyzing the actual oxidation states, we ran into a bit of trouble with a fractional charge. And a problem like this, it should be very easy to see what's actually going on because they pair up really well. Okay, the manganese has to pair up with the manganese, and the SO component must pair up. So we know splitting up the half reactions is not relatively difficult. Just like almost all the cases, we don't actually have to identify, what's being reduced and what is being oxidized. That will actually come out afterwards. After we do it, we could actually easily identify it. It has to do with the number E's. Okay, the side that's getting the E's would be indicative of whether it's gaining or losing electrons. So we know that these are going to be the half reactions, so we're just going to do this. All right, so I'm going to say Mn whole 4 minus 1 gives me my Mn plus 2. And likewise, S2O3 minus 2 gives me my S4O6 minus 2. Number-wise, I'm good with this one. 1 and 1. I can start working with the number of MNs are the same. Oxygens, so I'm going to add my waters, 4 H2Os. Okay, then I got to get rid of my H's by alleviating the H's with 8 H plus. Then I have to get rid of the charge issue by doing, what do I actually have here? I have plus 2 on this side, and as of right now, I have plus 7 plus 5 E's. Okay, when I add my 5 E's, I have plus 2 on both sides. Working on the bottom one here, doing my sulfurs. I have a way to do my oxygens. I'm going to wait on oxygen. My sulfurs, though, I can stick a 2. Get my sulfurs correct. Working out on oxygens, oxygens are actually already balanced. Okay, they're already balanced. I can actually skip the oxygens and skip the H's because I don't have to deal with H's and go straight to my electrons. All right, I have negative 4 on this side, negative 4. All right, and on the other side, I have my negative 2. So hopefully it's obvious that on this side I need 2 E's. Okay. Now that we have the half reactions balanced, now we can actually identify which one is the redox, which one's the reduction and which one is the oxidation. Okay, gaining electrons is the GER, it's the reduction, and that's going to be my top reaction. Okay, I'm gaining electrons. Okay, gaining electrons. I'm losing, I'm on the Leo side on the bottom because I'm losing electrons. So after we actually do the half reactions, we could actually work backwards to identify which is the oxidation, which is the reduction. In fact, in some ways it makes life easier. Since I have those underlined, we have to meet these up in the middle. Okay, we have to mix them back up into one reaction. Where does 5 and 2 come together? And that is at 10. So working it out, I'm going to multiply this reaction by 2, this reaction by 5, and then add them up. When I do that, I have 10E minus plus 16H plus plus 2MnO4 plus, you can already see I'm going to run out of space, 10 S2O3s. And those are -2. Yields, okay, I have to write a little shorter here. 2Mn plus 2 plus, what am I dealing with? 8 waters. Plus 5 S4O6 plus lastly my 10's. Crossing out like terms, E's and E's are gone. Can we cross anything else out? I don't believe so. Just to do a check, and we didn't do this in class, if we did everything correctly, not only will it be traditionally balanced by the number of atoms on each side, and you can check that, 16 H's, 16 H's. Also, it will be charged balanced. And what I mean by that is, when you look this guy over, you have 16 positives minus 2 gets me to 14. Minus 20, okay, gets me to positive 6. So on this side of the equation, all right, just so we can see it, we have plus 6. On this side of the equation, we have 2 plus 2's, gets me to plus 4. Okay, plus 5 negative 2's gets me to negative 10. So when I add up both of these, guess what? Plus 6. All right, and I realize I'm off the board here, so I'm just going to write over here. Plus 6 and plus 6. Okay, so we're definitely balanced in every sense of the word, and you would be very, very hard-pressed to do this with traditional balancing techniques. You basically have to do it this way. Not always the case, but in a lot of cases it is. Now, the reason why we're doing this is to talk about not just our balance in acidic, but also balance in basic. And it's actually very, very easy. It's just one step. And you can do it, that one step, almost at any time. A lot of people, I didn't put it at the end. You can either do it before you combine the half reactions or at the end. I'm just going to do it at the end. All right? If I rewrite the actual answer, okay, the actual answer to the balanced equation is 16H plus 2 MnO4s plus 10 S2O3s yields 2 Mn plus 2s plus 8 H2Os plus 5 S4O6. Okay, that was our final answer. Alright, I can get rid of this now. That was our final answer, and right now I'm going to switch this from an acidic to a basic balancing. And it's relatively easy. It's one of the more painless operations. Okay, of all the steps, it's right there with one of the easier steps. Okay, what I'm going to do, first of all, hopefully you can see my goal is to get rid of H plus. Okay, H plus, that equals acid conditions. So this was balanced in an acidic solution. I want to get rid of my H's and turn it into a basic solution. And the procedure is as follows. What I have to do in order to get rid of the acidic quality, I have to add something to both sides. All right? Just like in algebra, you're allowed to add, as long as you're going on both sides of the arrow, you're allowed to add anything. Okay? Mathematically wise. We can't add just anything, but we know it's basic. So in order to get rid of my H's, I can add, and I'll do it in a different color. I can add 16 OH's. Alright, so I'm going to add 16 OH negatives. I'm going to do that to both sides. Okay, I know it's a little hard to see, that's a 16 OH negative. Now, what did I actually change? Well, I added my 16 OH's to both sides. I'm allowed to do that because I'm in basic solution. I'm not breaking any laws. What happens to my H's? Well, they link together and make 16 H2O's. Okay. What happens to my OH's over here? Well, they just stay there. 16 OH's. Okay, so I have my 16 OH's on this side. I don't have OH's anymore or H plus. I have 16 H2O's because they link together. Well, I can rewrite my final answer now. Get rid of some waters and rewrite my absolute final answer as 8H2O plus 2 MnO4 minus plus 10 S2O3s yields 2 Mn plus 2 plus 5 S4. Really struggling here with the marker. 06 plus 16 OH negative. All right, I apologize. I think the battery in my marker is getting a little fatigued. Now, if you go through the mathematics, just look at the hydrogens, you'll see that you have 16 hydrogens on both sides. Everything else remains balanced, okay? But there's no hydrogens. It's not acidic anymore. It's basic. So our procedure, if it's in basic solution, if they dictate us to balance this in the basic solution, we do everything the same, and then we add OHs to both sides and negate the H plus, turn them into waters, reduce the waters, and write whatever you're left with. All right. The only thing we need to know for doing any more of these problems is perhaps the last question, this guy. Okay, it doesn't seem to make any sense whatsoever. Zn yielding ZnOH4, 2 minus, plus H2. Why doesn't it seem to make any sense? Well, where are the oxygens? Where are the the H's coming from? And it's quite simple. Okay, don't forget the name of the chapter. Okay, the name of the chapter is aqueous solutions. Okay, my zinc, it's not written, but because it's aqueous, you can always say H2O. Okay, and when you do that, everything will work out. Hopefully it's obvious. You're going to have this reaction, and you're going to have that reaction to do our traditional balance with our rule set. And then because this is on the basic side, you would also follow up and add the OHs.